Good morning, guys. Welcome to the third numerical session on circular motion. So let's start with our first numerical. Figure shows a smooth track, a part of which is a circle of radius r. A block of mass m is pushed against a spring constant k fixed at the left end and then released. Find the initial compression of the spring so that the block presses the track with a force mg when it reaches at point A where radius of track is horizontal. So I have been given a track like this, and this is my point P where my radius is horizontal, and this is spring, and block of mass m is is pushed on the block using compression of the spring or stored energy by of the compression of this spring. So the energy stored in the spring will be given to the block, and block will travel along the track. I have question is asking that what should be the minimum compression of the string. That means how much minimum energy should the spring provide to the mass so that it will reach until this position. It will reach until this position. So let's assume spring is compressed by compression of x. Store energy in the string will shoot the block on the track and will travel until point B. And what is the condition at point P which is given? The block presses the track with a force mg when it reaches P. That means when it is here, when it is at this location, block pushes radius with force of mg. That means if I had to calculate normal reaction, it will be equal and opposite, because if block pushes the track with mg magnitude of force, the track will push my block with same but in opposite direction of force, which will be mg. So at point P, from given condition, my n will be mg, and this n is acting as a centripetal force. See, it is along the radius and towards the center. So my necessary centripetal force will be mg. So mv square upon r will be equal to mg. So from here I will get velocity or speed of the block at mg, which will be equal to root of rg. Now I can apply conservation of mechanical energy from point A to point P. I can apply conservation of mechanical energy from point P A from point A to point P. Conservation of ME between A and P. So TE at A, total energy at A will be equal to total energy at B. So, what energies do I have at location A? I have spring energy. I have kinetic energy, and I will have potential energy. And at point B, I will have at point P, I will have KE at A and PE, KE and PE at P. So initially, when it is compressed, at that point, block is at rest. So V at A will be equal to 0. For our condition, this is ground. So H is 0 for at point A. So KE and PE will be 0 at this point. So only energy at point A will be spring energy, which is given by half of kx square, where k is spring constant and x is compression. What is the kinetic energy at point P? It is nothing but half of mv square. What is PE? What is vertical displacement? H is equal to R. So it will be mgr. If I put V equal to root rg here, I will get half of kx square equal to half of mrg plus mrg. This will be equal to 3 by 2 mrg and half of kx square. 2 will get cancelled, and from this I will get minimum value of compression, which will be equal to 3 mrg upon k raised to 1 by 2, or square root of all this. See, in mechanics, there are some tools you will have to use many times, like conservation of mechanical energy, conservation of momentum, in that conservation of linear momentum, conservation of angular momentum, force balances. You will all the questions in solid mechanics will revolve around this part. However difficult may the question be, but question will involve the basics of mechanics. You will have to use that basics. You will have to use that basics to go and reach until this difficulty. See, this might feel difficult for you, but when I solve this, I have only used force balance. In that term, I can say it as a conservation of linear momentum and conservation of mechanical energy. Let's go to our second question. A small box of mass m is kept on a fixed smooth surface of radius r at position where radius makes angle of 30 degree with the vertical. The box is released from this position, and questions are: what is the force exerted by the sphere on the box just after it released? That means at theta equal to 30 degree with vertical or positive y-axis, and find the distance traveled by the box before it leaves the contact with the sphere. We have seen this case. This is the case of motion of particle along the circumference outside of the sphere. So, if I only take this part of the sphere and initial position of my block is 30° with vertical, and let's assume at theta equal to at some angle theta, box is released its contact from box releases its contact from sphere. So here my v will be equal to 0 because I will have to, because of given condition, and here as box leaves contact with surface, normal reaction will be 0. So let's call this as point A, this as point B. If this is mg, my this angle will be theta degree. So this will be my mg cos theta 30. This will be my normal reaction, and if I use principle of centrifugal force, this will be my centrifugal force. For point B, same. This will be my mg. This will be my mg cos theta. By normal reaction will be 0. So along radially outward direction there will be only centrifugal force. Centrifugal force. So first of all, I have to calculate what is the force exerted by the sphere on box after the release. That means at theta equal to 30°, I will have to find contact force, which is nothing but normal force. So what will I do? I will just take radial force balance. So at theta equal to 30°, where V is 0 because it is at rest, is kept on fixed and it is released. That means it was at rest at t equal to 0. Summation of F radial will be equal to 0. So if I take n plus mv square by r minus mg cos 30 equal to 0. Here this will go to 0 because v is 0. So my n will be mg cos 30, which will be equal to root 3 by 2 mg. So this will be the force exerted by the sphere on the block. So when it leaves the contact, normal reaction will be 0. Normal reaction will be 0 because for us to have normal reaction, there should be contact between two surfaces. So here mv square by r minus mg cos theta will be 0. Same f summation of f radial equal to 0. So from this my v will be square root of rg cos theta. So let's do the for energy conservation or energy balance between these 2 points. First, for that I will have to find vertical h, and that h will be, if I do trigonometry for this triangle, this distance will be my this distance will be, this total distance will be r cos 30, and this distance will be r cos theta. So h will be r cos 30 minus r cos theta. So it will be h r into cos 30 minus cos theta. So let's take energy balance between point A and point B. So delta KE will be equal to delta PE. So half of mVB square minus half of mVA square will be equal to mgh. VA is 0. So from this I will get V at VB equal to root 2 GH. See this case you will find this type of case in various MCQs. So if you have to do energy balance between two positions, delta K is equal to delta PE, and initial velocity is 0, then, and you know vertical displacement, then your final velocity will be always this under root of 2gh. So you can remember this, because while solving MCQs you will get to know, that, and you see the answers or hints given in the book, you will get to know that they have used this formula directly, because this is very common case. Initial velocity at some position is 0, and then after some vertical displacement velocity will change, which is v. So after vertical displacement of h, if we take energy balance, conservation of mechanical energy, v will be equal to root 2 gh, root 2 gh. So now I have two values of v. I can equate that. So rg cos theta will be equal to 2gh. I can put value of h from there. So rg cos theta will be equal to 2g into 2g into cos 30 minus cos theta. R cos 30 minus cos theta. Now I can solve this equation. I can solve this equation for theta. From here I get cos theta equal to 1 by root 3, and my theta, if you take it from log table, I will get 54.73 degrees. So for distance traveled is nothing but h. Distance traveled is nothing but s. Sorry, it will be s. So question asks is displacement, not this. In question I have been asked to find distance, so I will have to find length of this curve. So for that I will have to find delta theta. It will be equal to theta minus 30 degree, which is equal to 24.73 degree, which will be equal to, if I multiply this by pi by 180, I will get it in the radians. So I can find this distance s by s is equal to r delta theta. So if I find this value in radian and multiply it by r, distance travel will be 0.431 r. So this will be my distance travel. And if you have been asked to calculate h, so just put cos theta 1 by root 3 here, cos 30 here, root 3 by 2, and you will get value of h. Value of h. Let's go to the next question. I will draw the diagram first and then we will start to solve the question. So this is a system. The question is, a particle of mass m is attached to one end of weightless and inextensible string of length L. The particle is on smooth horizontal table. The string passes through a hole in a table and to its other end is attached a small particle of equal mass m. The system is set in a motion with constant angular velocity omega 1. The second particle moving in horizontal circle as a conical pendulum with angular velocity omega 2. Show that the length of portion of the string on either side of hole are in the ratio of omega 2 square upon omega 1 square. So this is string. One end of the string is on the table, and this system is rotating with omega 1. This system is rotating with omega 2, and particle which is hanging is following a conical pendulum motion. So I have to find that R1, so R1 plus R2 will be length of the string, will be length of the string. So my R2 will be L minus R1. So for the mass on horizontal table, the only force along radial will be tension and centrifugal force. So for M on table, summation of FR will be equal to 0. So mv square by R will be equal to, or m, that we can also use m omega 1 square R, because we have to use omega 1 omega 2 will be equal to T. So this is my first equation. So as string is the same, this tensile will be also T, but now if this is mg and this is theta, then my this angle will be theta. I don't need to resolve mg. So if this angle is theta, this angle is theta, so this will be t cos theta and this will be t sin theta, and this will be m r2 omega 2 square. So again, for conical pendulum, f radial equal to 0. So t sin theta, will be equal to m r2 omega 2 square. This will be R2, radius of the circle, which is conical pendulum covering. And let's say this as R3. This will be R3. Summation of Fy will be equal to 0. So mg will be equal to t cos theta. So from this triangle, I can say that R2 will be equal to R3 sin theta. R2 will be equal to R3 sin theta, which will be equal to L minus R1 sin theta. So this equation 2 becomes T sin theta equal to m omega 2 square L minus R1 sin theta. So sin theta will get cancelled, and I will get T equal to m omega 2 square L minus R1. So if I equate equation 1 and 2, if I equate equation 1 and 2, I will get m omega 1 square R1 equal to m omega 2 square L minus R1. So m will get cancelled, and omega 2 square upon omega 1 square will be equal to R 1 upon L minus R1. So ratio of the string on opposite side of the table will be omega square of their angular velocity. Angular velocity. So let's go to the next question. So once again, ये क्या है, डायग्राम देखने के बाद ही when you see the diagram you should know that this is motion of particle inside a conical surface or funnel. A particle describes a horizontal circle on a smooth inner surface of conical funnel as shown. If the height of a plane of circle is above vertex is 9.8 centimeter, so this height is 9.8 centimeter, which will be equal to 9.8 into 10 raised to minus 2 meters. So I have been asked to find velocity of that particle. So if particle is following the circular motion, let's draw our, and this angle is theta, then this angle will be theta, inverse angles. Just a second. This is mg vertically downward. My normal reaction will be perpendicular to the surface, and my particles centrifugal force will be radially outward. If this angle is theta, this angle will be theta, so this angle is also theta. So this component of normal reaction is n cos theta, and this component will be n sin theta. N sin theta. So if I take force balance along f x r, summation of f r equal to 0, then I will get mv square by r equal to n sin theta, and summation of fy equal to 0, which will give me mg equal to n cos theta. If I divide equation 1 and 2, I will get v square upon rg equal to sin theta upon cos theta, and n will get cancelled. Sin theta upon cos theta equal to tan theta. So My V will be equal to Rg, then tan theta. I can find tan theta using the triangle. So if I take this triangle, so this angle is theta, this height is h, and this is r. So r by h will be tan theta. So my r will be h tan theta. Excuse me, just a second. Did I make some mistake? Okay, sorry, excuse me. I made a mistake here. Let me do this again. I made a mistake during while finding out the theta. So if this is my funnel, this is the horizontal motion, and this is radius, and this is theta. And if I draw my axis is here, this will be mg, my n will be perpendicular to the surface at 90 degree, and this will be mv square upon r. If this angle is theta, then this angle will be theta, then this angle will be 90 minus theta, and this angle will be theta. So I made a mistake there. I'm really sorry. I got confused. So this will be n cos theta, and this component will be n sin theta. Now I can take, this will be the same, r equal to h tan theta from summation of fr equal to 0, mv square by r equal to n cos theta, summation of fy is equal to 0. So mg equal to n sin theta. So let's divide equation 2 by 1. So what will I get? Mg upon mv square by r equal to tan theta. N will get cancelled, and sin theta upon cos theta will be equal to tan theta. From this I can find, rearrange this and write it as r v square equal to rg upon tan theta, because m will get cancelled, and I can put now value of r from here, so v square be equal to h tan theta into g upon tan theta. So tan theta got cancelled, and v will be equal to root gh, root gh. Put the value of g 9.8, h की value 9.8 into 10 raised to minus 2. सो आपका आंसर होगा V will be equal to 9.8 into 10 raised to minus 1, which will be equal to 0.98 meter per second. Meter per second. Sorry for the mistake, but I corrected the mistake. So now this is the correct answer. Let's move on to the next one. A car starts from rest. A car starts from rest in a circular flat road of radius r with an acceleration a. Find the distance of car. Find the distance the car will travel before it starts skidding. तो क्या है, एक कार है वो along the circular road स्टार्ट कर रही है एक कोई तो पोजीशन से वेयर u इज इक्वल टू 0, क्योंकि इनिशियली रेस्ट पे है, एंड ऐसे ऐसा पोजीशन का वैल्यू निकालना है, डिस्टेंस का वैल्यू निकालना है एस एस कर्व का, कि जहां कार स्किड करना चालू कर दे. सो वी नो दैट at turning, if it is a circular flat road, that means there is no banking, it is unbanked road, then necessary centripetal force will be provided by friction between tires and the road. So if net force which is created by net acceleration exceeds the limiting friction, then car will skid. So it is given that ये कार ए एक्सेलरेशन से स्टार्ट कर रही है. हाँ, तो ए एक्सेलरेशन क्या है, ये लीनियर एक्सेलरेशन है, तो ये 80 होगा. ए क्या होगा, 80 होगा. तो ये लीनियर मोशन के लिए हम v का मतलब स्पीड का फॉर्मूला निकाल सकते हैं यूजिंग लॉज ऑफ मोशन. सो 80 a है, u 0 है, तो हम v मतलब स्पीड एट दिस लोकेशन एंड डिस्टेंस ट्रेवल्ड का इक्वेशन फाइंड आउट कर सकते हैं किससे, v स्क्वेयर इक्वल टू u स्क्वेयर प्लस 2as को यूज करके. तो यहां ये 80 होगा, बट 80 इक्वल टू a, तो v क्या होगा, स्क्वेयर रूट ऑफ 2as होगा. बट यहां ओनली will there be only 80? No. If this is a circular road, there is going to be a centripetal force, or else there won't be circular motion. So this FCP will be equal to MACP. So my A centripetal acceleration will be equal to v square upon r. If I put value of V from here, I will get 2as by r. So if I have to find net acceleration, net acceleration, I will have to use a net equal to, as these two accelerations are perpendicular, I can use acp square plus at square. So if I put value of acp and at which is equal to a, I will get 2as upon r bracket square plus a square. So if this is a net, my f net will be m into net acceleration using Newton's second law. So my this net force will be m into 2 as by r square plus a square raised to 1 by 2. So for preventing skidding, frictional force should be greater than F net. But for skidding, my this force F net should be greater than or equal to frictional force. So what is the limiting value of this frictional force? It is nothing but mu s n, because static coefficient of static friction will give you higher value of frictional force, which is equal to mu s mg, mass of car. So m into 2as upon r bracket square plus a square will should be greater than or equal to mu s mg. Will get cancelled, will get cancelled, and if I take this a to the other side, this is raised to 1 by 2. So let's first of all let's square, let's take square of this equation. So this will be mu square into g square. I can take this a square to another side, so I will get 2as by r bracket square equal to mu s square g square minus a square. And if I rearrange this to find s, I will get s equal to mu s square g square minus a square into r square upon 4a square raised to 1 by 2. This will be my limiting value of s. So if this car travel distance of this much with acceleration a, it will start skidding at after this much of distance traveled, So let's see the next one. A particle is attached by means of two equal strings to point A and point B in the same vertical line, and that particle describes a horizontal circle with a uniform angular velocity. If the angular speed of particle is 2 into root g by h, with vertical distance between AB each h, what is the ratio of the tensions? What is the ratio of the tensions? So first of all, let me write what is asked. T1 by 2, T2 is asked, and what is given? Omega of this, because this is covering some horizontal circle. So omega is 2 into 2gh upon h is to 1 by 2. So this will be my mg. If this angle is theta, this angle will be theta. So if I, and this angle will be also theta. If I resolve T1, T2, then this will be T2 cos theta, and this will be, T2 sin theta. Similarly, this will be T1 sin cos theta, and this will be T1 sin theta, and radially outward will be my centrifugal force, which will be equal to mr omega square. So I have resolved all the forces along xy direction. So if I take summation of fx equal to 0, I will get m r omega square minus t sin theta, t1 sin theta minus t2 sin theta equal to 0. So from here, I will get T1 plus T2 equal to mr omega square by sin theta. If I take summation of Fy equal to 0, I will get T1 cos theta minus T2 cos theta minus mg equal to 0. So T1 minus T2 I will get from this equation will be equal to, should be equal to mg upon cos theta. This is my equation 1, and this is my equation 2. So if I add this equation, I will get value of T1, because T2 will get cancelled, and by solving this equation I will get T1 equal to 1 by 2 m r omega square upon sin theta plus mg upon cos theta, and T2 will be, and if I then put my value of T1 in either of the equation, I will get T2 will be half of, or just subtract equation 1 from 2 or 2 from 1. Using that, I will get value of T2, which will be equal to half of mr omega square upon sin theta minus mg upon cos theta. So if this length is h, this length will be h by 2 and this length is r. So I can draw this triangle h by 2 r and theta, and using this I can get, I will get tan theta equal to r upon h by 2, or from here r will be equal to h by 2 into tan theta, and I have been given omega equal to 2 2g upon h raised to 1 by 2. So if I put values both of these values here, I will get value of t1. Put the value of r and omega here. This is just trivial work. Do it properly. I am going to write the final answers directly. T1 will be equal to 5 mg upon 2 cos theta, and T2 will be equal to 3 mg upon 2 cos theta. So ratio of this T1 by T2 will be mg will get cancelled, 2 cos theta will get cancelled, only will remain 5 by 3. So whatever may be the system is, कहा भी अगर स्ट्रिंग टाई किया है, कहीं भी अगर स्ट्रिंग टाई किया है, लेंस दिए हैं, या ऐसे वर्टिकल मोशन में घूम रहा है, हॉरिजॉन्टल मोशन में घूम रहा है, बट इफ यू फाइंड द करेक्ट, if you identify correct forces acting on our particle which is traveling along circular motion, either it may be the vertical or horizontal, if you identify all the forces and their direction, and using force balance, and after identifying forces you will either have to use force balance or conservation of mechanical energy to, here we have only used force balance, we haven't used conservation of mechanical energy. Most of the questions in circular motion will be solved by using these two principles only, force balance and conservation of mechanical energy. However complicated may the system be, if there is string, there are going to be tension. If there are surfaces and particles, there is going to be normal reaction. Of course, if it is a circular motion, there is going to be centripetal force and centrifugal force. As the particle is made of matter, it has mass, so it will have weight. So if you identify directions and magnitude of all the forces properly and resolve all the forces properly along their respective coordinate systems, then answer is not difficult. Answer is not difficult. See, अगर सिस्टम को देखा तो सिस्टम थोड़ा डिफिकल्ट लग सकता है किसी को, बट एक बार फोर्सेस निकाले एंड फ्री बॉडी डायग्राम निकाला तो सिर्फ आपको एडिशन ही तो करनी है. I am just adding the forces and solving the linear equations which we have been solving from 8th standard. Just these are equations in the form of mg r omega theta. That's why these equations are long. But haven't we solved this type of equation, x plus y equal to 10 and x minus y equal to 5, and then find t1 and t2. Similarly, when we are doing the similar thing, so don't be afraid of systems like these, which can look difficult, but are very easy. Even in the last problem where we took the table and there was a particle which was following horizontal circular motion on the table, and conical pendulum, second particle was following conical pendulum below the table. Even that system, one might feel that system is difficult, but solution was very easy. But when you will find the solution, finding solution is easy if you know the basics of mechanics. If you know the basics of mechanics, you will not have any problem solving this type of examples where system might seem difficult. Now let's finish our session here. Let's finish our session here. This is our last example of this session. We may have one more session on circular motion, which will only cover some MCQs. So that session will be of MCQ. We will see that when we can take that session. So I think this is enough for today. Thank you for listening, and have a nice and productive day. See you.